Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parallel and perpendicular lines, specifically how we can describe the equation and the slope of lines that are either parallel or perpendicular to the x or y axis, and we'll do it in 5 minutes or less. So when we are talking about parallel lines, let's look at this very first one right here, parallel to the x-axis. So my x-axis is this horizontal line right here. My y-axis is that vertical line right there. So if we want to find a line that is parallel to the x-axis, let's just make one right down here. Make it nice and easy. Let's make it a line right there. And so here's what we want to find is the equation. And take a look. This parallel line is, like I said, parallel to the x-axis. But it also happens to be perpendicular to the y-axis. So our y-axis is right here, and it makes a right angle to the y-axis. So when I'm describing the equation, it's going to be for a line that is either parallel to the x-axis or perpendicular to the y-axis. And take a look at my x-coordinate, right? So my x-coordinate is just -8, -7, it goes on and on and on. So we're going to describe this not in terms of the x-coordinate, but the y-coordinate. Take a look at my y-coordinate. No matter where I go, even if I'm just looking at the whole numbers, right, even though this is continuous data, no matter where I go, that y is going to equal -6. So when we are looking for an equation for a line that is parallel to the x-axis, we actually describe it in terms of its y. Y equals -6. That's the entire equation. It's not slope-intercept form. So let's take a look at this other one, parallel to the y-axis, right? So my y-axis is this vertical line right here. So then if I want to draw a line that is parallel to that vertical axis, well, then I need to draw another vertical line. So let me draw this one right here. Let's draw some arrows, and I'm going to describe this in terms of its x-coordinate, right? So no matter where I go on my line here, you notice that my x-coordinate is going to be 2. So it's kind of interesting when I'm drawing a line that is parallel to the y-axis, the equation is x equals 2 in this case, or x equals something. But you notice that it's also perpendicular to the x-axis, because here's my x-axis right here. And so it's perpendicular to the x-axis. It's formed at a right angle. So it's the exact same thing. So x equals 2. So depending on whether you want a parallel or perpendicular, that's how you would describe the equations. Now, what is the slope of each of these lines? All right, so let's go back to this y equals -6 right here. So let's look at my slope. All right, so remember your slope is rise over run. Okay, so that is your change in y over your change in x. So let's say for every single x that it goes over, right, so the x is going to equal 1. It doesn't go up or down any. It's 0. Right? So for this, the slope is going to equal 0, because no matter which 2 points I'm looking at, let me look at here and here, right, it's going to go up or down 0, 1, 2, 3, 4, 0 over 4. So if you have a line that's parallel to the x-axis, right, it's got a slope of 0. What about a line that's parallel to the y-axis? Well, if I'm going to change 2 points here, right, so let's just pull 2 points, okay? So I'm going to pull right there. So rise is going to be 2. If I'm going from here to here, right, it goes up. But it doesn't change any x. The run, it doesn't go side to side. 2 over 0. What if I do these two right here? If I go down 1, right? So that's going to be -1. Still, it doesn't go side to side 0. So you cannot define that, because anything divided by 0 is actually undefined. It's impossible to have -1 or 2 groups of 0, so that's how you define them.